know nothing about a bisector? It's kind of like a trick question. I think actually what it's missing is, what it's missing to become a perpendicular bisector are those two congruent marks. Do you agree? So this one's nothing, right? Number 11, altitude. Now, if it doesn't have these, but if it had these two marks, it's not only an altitude, but what else is it? It's a median, an altitude, angle bisector, and perpendicular bisector. Because in an isosceles triangle, isn't an altitude all of those things? Yes. Okay, so make sure. All right. No, if it was. If it wasn't marked that way. If you look at the next page, this one didn't come out. These aren't darkened real quick. But I wanted to look at number 5. This is the highlighted segment in number 5. It's going to be a little thinner so you can see there. So that's the darkened one. What is that? Yes. It's an altitude. And actually, I've drawn over here on the sideboard all 3 altitudes in a right triangle. What is the name of that point, by the way? If it's a different currency, it's 3 altitudes. Orthocenter. But you need to know that name, okay? So the orthocenter happens to be the vertex of the right angle. Interesting. That is an altitude. Which one of these is 4 segments? It's altitude, median, angle bisector, and perpendicular bisector. One of those is. Which number is it? Number 10 is only an altitude. Number 4. Okay. Number 4 is altitude. It's also a median. If it's both, and it's an isosceles triangle, it's also an angle bisector, and it's also a perpendicular. So number 4 is all. No one should be writing anything, right, Alex? Pencils up. Okay. Are there any questions about the segments? Right. If you would, put all your packets together in one pile. I'll come around and collect those from you. The whole packet. So I want to talk a little bit about your MYP project that I just gave you. We need to pick a due date. It's not going to be super time-consuming. But it is a little bit of an investigation. You'll notice on the back I'm evaluating you this time on a different criteria that I have before. This is called investigating patterns. If you look on the back, this is like the rubric, the MYP rubric that is assigned here. And these are just the different levels, okay? Proof, justification, explanations are what you want to be thinking about for each of these things. We need to have this done within a week or so. So I'm going to give it to you today. I'm looking at the calendar. I think next Friday we don't have class. Well, I'm looking at the wrong. Hang on, I'm looking at the wrong date here. December. We actually do have it next Friday. That's fine. December 5th is the due date for this. Okay, so go ahead and put December 5th, and that's fine. Okay, but I want to talk you through it a little bit. So you'll notice on this there are 3 parts to it. Okay, so I want you to kind of put some notes in the margins to kind of help you a little bit with guiding you along. Part A, if you actually look at it, we're going to be constructing an angle bisector. Only one. Okay, you're going to draw a triangle. We're actually going to spend some time looking at doing that. You have to do it in class. So I'd like to actually look at that again, and maybe either at the end of class today, or we'll do it the day to get back from Thanksgiving. Either one. Okay. But you're going to construct an angle bisector. All right. You know how to do that because we did that last time, right? We know how to construct an angle bisector of a triangle. And you'll notice when you construct an angle bisector, which I kind of gave you an example here, I want you to look at some ratios. Remember what a ratio is? What's a ratio? It's like a fraction, right? You're comparing fractions, right? So we're going to be looking, if you look at A over B, so the two sides divided by A divided by B, you're going to compare that to X divided by Y. So you're going to make your own triangle, and you're going to go ahead and construct. You might want to say with a compass. So part A, you compass, and then you're going to need to use a ruler to actually measure the length of A, measure the length of B, measure the length of X and Y. Okay? So you're going to be using a ruler and a compass for part A. Fair enough? And then you notice it also says to compare your ratios to another student. So I'd like to have you go ahead and do that part before next class. Okay? Just go ahead and construct an angle bisector, and then we'll compare that. You have enough people at your table, 2 to 3 people is all you need to compare. You'll need to tell me the names of the people that you compared it to, though. Okay? So we can work on that on Monday. We get back from Thanksgiving. Just be prepared for that part. Part B is what I want to practice with you today. Okay? So part B, if you read part B, we're talking now about perpendicular bisectors. But notice what it says. It says get out a piece of paper and cut out a large, acute scalene triangle. Now, I did not cut out an acute scalene triangle. Mine is a right triangle. Okay? And Jessie, hold yours up. She did an obtuse triangle. And that's okay for what we're doing today. Okay? But where you're going to start for the project, and notice what it says. It says fold the triangles to form the perpendicular bisectors of each side. So that's what we're going to practice doing today. So you're going to need to watch me, and then I want you to do it with your own. Okay? If I'm going to make a perpendicular bisector, let's say the side I have holding up the bottom, okay? I'm going to take each of these 2 endpoints and literally just marry them together, and then I'm going to fold the sector, and that's it. Okay, so that right there is the perpendicular bisector. Go ahead and try yours. Take your triangle, pick one of the sides, it doesn't matter which one, pick one side, marry the endpoints, and then fold the perpendicular bisector. You might want to, when you fold it, kind of make it a darker line, like use the edge of your pencil maybe. You have a compass here, you can just kind of darken the edge of the triangle, the edge of that perpendicular bisector, just so it shows up a little better. Mine's not even. Works a little better. Just folding a perpendicular bisector. Okay. I just made it a little darker so I could see it. Okay. No big thing. Okay. Notice it doesn't go through my vertex. If you made an equilateral triangle or an isosceles triangle, it probably did go through your vertex. No big deal. But it should bisect this side and it's perpendicular. Okay. Now I'm going to do I'm going to pick a different side to do. So I'm going to turn my triangle. And now I have this bottom side. And I'm going to make its perpendicular bisector. So remember, what do? I take the 2 endpoints, fold them together, marry the endpoints, and then fold. Okay, marry the endpoints and fold. So I have, right now, I have 2 of my 3 perpendicular bisectors. I want you to do all 3 of them. Wait, I just took this endpoint, this, and I put it together. And now I'm going to do one for the bottom. Which one haven't I done? I haven't done this one yet. I'm going to do this one. So you need to do all 3. Just take each of your sides and marry endpoints. With each of the sides and marry endpoints. So if you look at mine, okay, I have all 3. Yours should intersect in a point. Because perpendicular bisectors intersect. What is the name of the point of concurrency for perpendicular bisectors? Circumcenter. Because mine's a right triangle, look where my circumcenter is. It's on the hypotenuse. Okay? Who has one that's folded, all 3 of them folded? Anybody? Is yours big? All right, open yours. Is yours a right triangle too? Anybody have a different triangle than a right triangle? That's big. Yeah, you have all 3 of them? All right, let me see. All right, so this is, you only have this one. Okay. Alright, this is kind of hard to see. Fine. But he has two lines crossed right here, and then one going straight down. His point of concurrency is right here in the middle. Do you see that? Mine was on the hypotenuse. If you notice, so you know how to fold a perpendicular bicycle. That's really the point of this exercise. It's just practice for us. If you keep reading part B, it says, do the bisectors intersect? You should have an answer to that really already. Okay? Notice it's asking you to measure some distances. You might want to write in the margin here that or circle or underline or highlight the word fold because part B is paper folding. You're not using a compass in part B. Part A, you're using a compass. Part B, you're paper folding. You are going to need to use a ruler as well because it's asking you to measure some distances. And then it also tells you at the very bottom, investigate the point of intersection when there is an acute triangle, a right-angled triangle, or an obtuse triangle. Bless you. So here's what you're not going to do. You're not going to get a bunch of triangles and turn this into me looking like this. Okay? Because I will lose all these little triangles. Do you agree with that? So what you're going to do is you're going to do your paper folding. You're going to have, you might want to highlight that last sentence of part B. You're going to have to do at least 3 paper folding triangles. You're going to have to do a scalene triangle like you did earlier, which is an acute triangle. You need to do a right triangle, and you need to do an obtuse triangle. Okay? So, and what you're going to do is once you folded them and whatever, you're going to glue them to a piece of paper so they don't get lost. Is that okay? So just make sure that you're gluing these down, like use a glue stick or whatever, so that they don't get, I don't know, where they end up. Yes? I'd rather them be on a piece of paper just because that way, you'll see why when you do it. You need to figure out where the point of concurrency is for all 3. I'd rather not do a Ziploc bag. I'd rather you glue them down or tape them down or whatever. Okay? All right. Thank you for asking that question, though. All right. For part C only has 1 sentence or 2 sentences. This says draw a triangle and its 3 medians. It doesn't say construct it. It says draw it. Right? All right. So this one you can use a ruler to do. All right? So you're going to draw any triangle and draw in the medians. So you can use for part C, you can use a ruler to draw the medians. Just find the midpoints of the sides and then connect it to the opposite vertex. Well, just make sure I'm clear. Part A, you have to use a compass to construct the angle bisector. Part B, you're going to be paper folding to find the perpendicular bisector. And then part C, you can just measure with the ruler. Are we okay with the difference? All 3 parts. Okay.
Wait, so you're saying that we don't have to use a compass?
No. You can use your ruler. Okay? All right, I want to make sure I'm clear with the directions on this. You are going to be investigating some things, noticing where the point of concurrency is, for example. You're going to be measuring the distance from here to wherever and looking at a ratio and some relationships. What we do when we get back from Thanksgiving, that Monday we get back, will also help you. Because you can keep your paper folds or you can throw them away or whatever. I would keep it to remind you how to do it, just out of curiosity, but we're done with that now. We're actually, when we get back from Thanksgiving, each one of these in the flip chart is going to have a theorem that we're going to write underneath it. Okay? There is a relationship amongst the perpendicular bisectors. There is a relationship of the angle bisectors. Okay? So we're going to look at those. But we're first going to start with the midsegment. Okay, so if you would, let's go ahead and look at the midsegment real quick. And I want to talk about the properties. So these 2 properties, if you would, you need to write underneath your flip chart on your midsegment. Okay, these are some truth statements. Your NYP project for now can just go back in your binder. And let's go ahead and write what I've highlighted here. These 2 are the properties of midsegments, and they should go underneath your flip chart for midsegments. So midsegments have 2 properties, okay, that we're going to use. One is that the midsegment is always parallel to the third side, and that midsegment is, the length of the midsegment is half of the third side. And we're going to use that last property here to answer this question, or to find x, y, and z. So this is one that you have as an example on page 10, so if you'll find that for me, so you'll copy it down, it's already there. And we're going to figure out what x, y, and z are. So find x, y, and z here, and then let's figure out if we can find the lengths of those. So I'm going to give you a minute to investigate it, see if you can think about an answer, how you could use the property of midsegments to answer it. Make sure you realize that we have midsegments here. Can you look at and recognize we have midsegments to begin with? And then we'll look at how to answer it. So it looks like quite a few of us got it on our own, which is great. Let's talk about why the answers are the way they are. Okay? So let's start. Let's first make sure we recognize that we have a midsegment. So let's look at this. Is that a midsegment? What I've highlighted right there. The endpoints are midpoints. Point R is the midpoint of AC, and point S is the midpoint of BC. So we do have a midsegment. So its length is going to be half of the third side. So it's going to be half of x. So x has to be 12. Good. Okay. We're going to use that same idea for this midsegment here. This is also a midsegment, the green one. It's half the length of y. So y would be 4. Very good. All right, now we have the last one. We have this is a midsegment Z, and Z is half the length of this last side over here, so Z must have a length of 5. Good. All right. So we can use that idea of midsegment and its length to answer some questions. Okay? Okay. So I'd like to go ahead and now construct it. Okay? So on your flip chart here, you're going to need a compass. We are going to be actually constructing a midsegment here. And we have to think about what the definition is. So grab a compass if you don't have one. So with our construction here, we have to, I'm showing you my construction on my own paper before we actually do it. But we're actually looking for midpoints. So I want to find, and don't draw this on your paper, but for example, I want to find that midpoint. And I want to find that midpoint, and then we'll just connect them. So we're really just on the lookout to construct the midpoints. How did we do that earlier this week? Or was it last week? It was last week. How did we do that? How did we find a midpoint? Remember, what construction do we use? Sophia. Okay, which is what construction? Yes, bisect a segment. Okay, so we're going to bisect a segment. We have to remind ourselves how to do that. So I'm going to take this compass, and I'm going to bisect this left-hand side of my triangle. All right, so here we go. We're going to construct a midsegment. So I'm going to take my compass and put it on the end point. What do I have to do with the spread of my compass? Make it more than half. More than half. Ooh, I think that's more than half anyway, so that'll work. So more than half. And then I'm just going to make an arc this direction. Come over here, the other end point, and make a big arc in the other direction. Now mine was really small. Can I redo mine because my spread wasn't obviously more than halfway. So I'm just going to redo it real quick just to make it a little bit more clear. If that's okay. All right. So I'm going to just move my spread a little bit more. There we go. And honestly, rather than make a big arc, I like to just make an arc above and an arc below, just so it's not quite so messy. But that's just me. If you make one big sweeping arc, I'm totally cool with that. Because honestly, the problem with my way is that it's not always long enough. Just like what I just did, isn't long enough. Okay. Hang on. Doing a compass construction is so awesome. Okay, there we go. So I'm not going to draw the line to connect those. Okay? Because I don't want the line. I'm sector, I'm only looking for the midpoint. So I'm going to take this straight edge, and I'm just going to line it up with the 2 points. So let's see if I can get this to work. All right, so I'm just going to use my straight edge. I'm just going to try to line these up. Sometimes it works, sometimes it doesn't. There we go. Up. All right, I'm just lining them up, right? And then I'm going to take my pencil, and I'm just going to mark the midpoint. Okay? That's all I've done. Found the midpoint. I have to do, so you have to make sure that you're using your ruler and you're lining up the two points, the 2 X's, and finding the midpoint. Yes, ma'am. I don't want you to do the line. I said not to draw the line. I only want the midpoint. So if you need to carry it, there's extra copies back behind my desk. If you messed up your construction and you would like to redo it, there's extra little pieces of paper back there. All right, I need to do the same thing on the right-hand side, so I'm just going to change colors real quick, just so I have a different perspective. And I'm going to actually make the mid-segment over here, so I make the midpoint over here as well. Just make sure we're more than halfway. I'll just make a big arc all the way this time, so to save myself from misery. All right. So I have my 2 points of intersection. I'm going to use my ruler. And I'm going to line up those as well and find the other midpoint. Well, the ruler doesn't want to move. Try this one more time. All right, we're going to estimate it to be about right there. Oh, you know what? My starting work needs to be realigned. So I've gone ahead and found my 2 midpoints. I'm literally just going to construct. I'm going to make it a blue segment. I'm just going to connect the 2 midpoints. Boom, I have a mid-segment. Okay, that's it. So I've constructed a mid-segment. You know how to do it. Nothing too hard. Just finding the 2 midpoints and you're done. Okay? Any questions about that construction? I think that was going to be easy. Much better than the altitude. Okay. So we're actually done with your flip chart for today. So if you want to go ahead and put that away for me. We are going to do 2 more constructions though. So you will need a blank piece of paper. If you will, guys, if you'll title it Constructing an Equilateral Triangle. Today's date is the 25th of November. Make sure you're putting the correct date on those notes. So constructing an equilateral triangle. Okay? Okay? The first construction that we're going to do. Taylor, do you want to take a picture? All right, we're going to first do an equilateral triangle inscribed in a circle. So we first have to talk about what inscribed means. What does inscribed mean? Say it louder. Inside it? Is that what you said? That's what I heard you say. I was excited. Yeah, it does mean that. It just means inside the triangle. Okay? To be more specific, the vertices or the points of the triangle are going to be on the circumference of the circle. So the points of the triangle are going to be touching the circle. Okay? The vertices are going to be on the circumference. So first thing we need to do is to start a triangle. So start a circle. So make a point on the middle of your paper, any point you want. And that's going to be the center of our circle. It's important that we have the center labeled. And then you're just going to go ahead and create a circle with your compass. It doesn't matter how big. I'm going to make mine this radius. And we're just going to literally just make a circle all the way around. Okay. Now my aspect ratio on the screen is off. So So mine doesn't look like a circle. I think mine looks more like an oval or an ellipse or something. So, but yours should be perfect and pretty. It's my smart board that's squished. You don't realize how off the aspect ratio was. I did this yesterday. I was like, ooh, it is. All right, so make a circle. Please keep the spread of your compass the same as the radius. So we already have it measured right now. We know what the radius is. Would you agree? Yes. Okay. And I'm just going to go ahead and make a mark somewhere on the circumference of my circle. I keep saying circumference. You know what that means, right? The outer edge, the perimeter of the circle. So just make a point anywhere. It doesn't matter where. Okay. And I have the spread of my compass at the radius, right? Okay. And I'm just literally going to go around the circle. So watch what I'm doing. I'm going to take my point, put it there, and then I'm going to make an arc. And I'm going to move my compass around the circle in such a way where I'm just literally going to go around the circle. Like we're playing this. Go around the circle. So you can do this too. You don't have to wait for me. Go all the way around the circle. I want you to tell me how many times the compass lets you go around the circle. Anywhere you want. You just make it. You just start point. Start any point you want to. Radius. How many times go around? 6. If I made 6 points of equal distance around the circumference of the circle. Now, don't do this, but what if, just watch me, don't actually do this. What if I connected all of these points? What kind of a figure would I have drawn? Pretend like that's I would not have a hexagon. I would have a hexagon. Okay. So I'm just going to draw it real quick. Don't actually do this. Because this is a construction we'll do eventually, later on in the year. But I have a hexagon here. It's actually a regular hexagon. It's a 6-sided figure. Okay? Notice that the diameter of the circle passes through the center of the hexagon as well. No big deal. All right. But we're not talking about a hexagon. We wanted to do an equilateral triangle. Does anyone have an idea how we can use those 6 points to make an equilateral triangle? Right, use 3. Doesn't matter where, which point I start with. Pick any point you want. All right. This is my favorite one. I don't know why, but I love it. Go ahead. Not parallel to it. What am I going to use? Rather than connect all 6 points, I'm going to connect every other one. I'm going to connect every other point. So if this is my favorite one, I'm literally going to connect every other point. And that, my friends, is an equilateral triangle inscribed in a circle. Okay? There is also, using this same picture, another equilateral triangle that we can draw. And I don't mean the upside-down triangle one that makes the pentagram or whatever. Not pentagram. What is that called? What is Star David, right? The 2 triangles. Yeah. No, that's not what I'm talking about. There's a smaller one. A smaller equilateral triangle that I can use, that I can draw as well. Which one?
If you attach the 2 bottom lines and the
Let me do a different color. Go ahead. Say it again. I'm sorry.
if you attach the 2 bottom lines and the point up to the
You just see right here? Okay. Oh, and I don't want to draw that big one. But what if I wanted to make another equilateral triangle? Not that 2. I don't want to go that far. What if I did these 2? Is that what you meant, Sophia? Yeah, these 2? Okay, and then do what?
and then bring them both.
Perfect. Bring them both to the center of the circle. We know that that is a radius. That's the spread of our compass, isn't it? Didn't we have it open that far? That is a radius. And guess what? Any point from the center to a point on the circle is also a radius. So that red triangle is also an equilateral triangle. Yes. However, that was not inscribed, is it? No. Inscribed means all the vertices have to lie on the circumference of the circle. So the black one that I've drawn is the actual inscribed circle. I'm sorry, inscribed triangle. The red one is just equilateral. Okay? If you want to color code yours so you know which one is which, that's a good idea. Sure.
I'm using my light.
So we'll we'll say that this one is our inscribed one, or you can just write it. And you can say that this one is not inscribed. But both equilateral. I think this is kind of an easy construction. It's kind of nice. Some of the constructions we do are easier, but this is one of the easier ones. I also want to construct another equilateral triangle. Okay, but this time I'm going to have you watch it on the video first. And I don't know, oops, we've already done that. I don't know if you know where to find those. So I'm going to show you. They're on our School Fusion webpage. So I'm going to bring that up and show you what I'm talking about. So here's School Fusion. Oh, I haven't logged in. Hang on. Let me log in. Now, when I log in on School Fusion, it's going to look a little different than when you log in. But Fusion Pages, let's go to our web page. We're block 1. So look up at the smartboard, guys. Okay? If you scroll down on our School Fusion page, underneath homework, where you can always find out where your homework is, there's something called links. Now, you guys don't have these you can't edit or anything. It's only me. But you'll see that we have the online textbook is there. You can quick link right to that if you use that. But here, if you click on this Compass Constructions, remember how we looked at this website a little bit at the beginning of the year, and you had to print out some of those worksheets? That's the link to it. Here are the worksheets. Here are the videos. So if I want to scroll down, there's so many of them. I want to look at triangles, and I want to look at an equilateral triangle. Okay? So let's click on this. And we're going to just watch step by step what's going to happen. So let's go ahead, and you're going to do this too, and we'll do it together in a minute, but let's watch it first. So we're going to have to start with some segment. Okay, this particular segment is AB. It can be any side you want. We're going to create an equilateral triangle whose lengths of the sides are the same as AB that's given here. Okay? So, and I also have to start with the point. Actually, Jared, would you turn that light off for me so we can see a little bit better? Oh, that's a lot better. Thank you. So we have this point also is where we're going to start it. So I'm going to take my compass and measure AB. And then from point P, draw an arc near. So go ahead and we're going to make an arc. Got to make another arc. Just make 2. Okay? Then I'm going to move my compass, a point Q. It doesn't matter where on this you mark it. It doesn't, just make a point Q on it. And then I'm going to make my compass, I'm going to make an X up there. And guess what? I'm going to connect R, P, and Q. And that's it. I've made an equilateral triangle with the lengths AB. Okay? So we're going to watch it one more time. Let's just run it from the beginning. And let's see if we can't try it on our own. Constructing an equilateral triangle with a given length. All right, you think you can do it? Let's try. I hope so. So, the first thing we need to do is we need to make sure that we have a segment drawn. So you want to make any segment you want. Mine's going to be this length. Okay? Jared, will you put those lights right back up for me? Thank you. All right. So I have those segments, those lengths. Okay? And I'm going to, oh wow, not that. I'm going to move my compass and I'm going to measure the length of my given segment. There we go. And I have to start with some point out here. They called it point P, I'll call it point P2. It doesn't matter. Anywhere you want. Okay, and then I'm just going to move my compass once I have it measured, move it to point P and make 2 arcs. Move it to point P, somewhere down here. Doesn't matter where. Okay. Make two arcs. Then you're going to go ahead and make point Q. If you remember from the video, point Q is anywhere you want on here. I don't care where. Just make a point. Any point on that first arc. And then I'm going to move the sharp point of my foot. By the way, PQ should be the same as your spread of your compass, right? I'm going to move the point, sharp point, to point Q now. There we go. And I'm going to make an arc. Uh-oh, what happened? I didn't make my arc long enough from point P. That's okay. I'm just going to come back over here to point P, and I'm just going to make my arc longer. So it crosses it. That's all. And then I'm just literally going to connect all those points. Q, a new point, Q, a new point. There you go. Done. All of those happen to have the same length as our given one. Okay? So this is constructing an equilateral triangle with a given length. How do we feel about the constructions? Good. They're pretty easy today, I think. Midsegment was pretty easy. And then we had three equilateral constructions. That was it. All right, we talked about your MYP project. What I need to talk about now is what your assignment's going to be. Before your homework is given to you, can we please look at this page again in your packet? We started with 15. We did 15, but I'd like to look at 12, 13, and 14 as well. We are done with the compasses at this point. So if you want to come put them back at the box, that's great. So I draw number 12 up here for you. And if you look at number 12, it says, what is the equation? And then find x and find the length of AC. So we have to write an equation. Everyone, when I look at this problem, immediately wants to do this, which is incorrect. They want to say that these two things are equal to each other. That's not true here. What would it have to, what would the segment, what would BD have to be in order for those two things to be equal? A median. And is it a median? Read the directions. It is not. Okay, correct. It should be 4x minus 10. What does it say that BD is? An altitude. So these two things that I'm writing here in black, the 4x minus 10 and the 5x minus 20, have nothing to do with an altitude. Unless it's an isosceles triangle, which we're not told that either. What does have something to do with an altitude? Sophia?
That BD, the angle, wouldn't that be
Perfect. So the equation that I want you to put for 12a is that this angle, if BD is an altitude, then 5x plus 10 is equal to 90. Agreed? Okay? That's what an altitude is. An altitude is a segment that is perpendicular to the opposite side. And then I'll have you solve for x. Okay? You solve for x, and then how would I find the length of AC? How would I find the length of this? What would I do? Once I found x, what would I do? Plug it in, right? Would I just plug x in both places, here and here, and add them together? Okay, we can do that. All right, let's look at 13. You'll eventually do it. I think part of your homework is to finish it. Let's look at 13. 13, what's the key word? Median. Highlight it, circle it, do whatever. It's a median this time. So if this is a median, what things are congruent? Yeah, now we have the equation that we want to write, right? These two things do equal each other because it says median. So that's the equation you're going to use here. And then again, you'll solve for x. Notice how much extra information I'm given, right? It's there to like throw y'all off more than anything. Let's look at 14 now. 14 is a little bit harder. What's the key word in 14? Angle bisector. So again, we're worried about angles. How can I write the equation here? This one's a little bit more difficult. See if you can figure it out. One second. Angle bisector is key. All right, Sophia said it first. Go ahead, Sophia. Tell me what you think.
Is 3x plus 10 going to be double?
Yes. Very good. If this is an angle bisector, what she's saying is that this is also 3x plus 10. Would you agree with that? So, what does that mean? What's the equation I'm going to write now? They don't equal each other. Well, they do equal each other, but x could be anything. I would say, like, you get x equals x. Yeah? We need this information, folks. We need that information. We need the measured angle ABC. Because that's this whole angle, isn't it? Angle ABC, right? So what can we do? We can use what we call the angle addition. We can say 3x plus 10. I can write plus another 3x plus 10, or I can just double it. Either way works. Is equal to the whole thing. Would you agree with that statement? You could say, you don't have to say times 2, you could say 3x plus 10 plus another 3x plus 10 is equal to 2x plus 3. Either way. But you did need that piece of information. Okay? All right, so part of your homework is going to be to finish this page. Okay? Finish page 10. Your other part of your homework is to do page 11, which is the 5-1 practice worksheet. Okay? Problems 1, 2, and 3 are very similar to these types of problems, but please listen. Problems 4, 5, and 6, can you look at those for me on the 5-1? Those are on graph paper. Those are coordinates. You need graph paper to do them. You're also going to need to use things like the distance formula, the slope formula. Okay? So this is kind of an homage to coordinate geometry. Okay? We're going to do a little bit with coordinate geometry in almost every unit that we do throughout the year. So we need to remember that distance formula. Do you remember it? Can you write it down for you, or can you look in your notes? You look in your notes. You have it. You have that section, right? So that's your hint. 4, 5, and 6. Use coordinate geometry and graph it on graph paper. Any questions about homework? Yes, ma'am.
This is exactly.
No, just page 11, just the 5-1, and then to finish up the equations we're solving on this page. Okay? All right. Homework's done.